Hello dear students, I am Dr. Chandrakala HT. In this video, under the topic data link layer, I'll be teaching you the concept of flow control. We'll be learning two methods of flow control provided in the data link layer. The first one is stop and wait, and second one is sliding window. Let us understand the meaning of flow control. As we all know, on a network, data transmission happens between the sender node and the receiver node. The receiver node will have some speed limitations as well as memory limitations. The receiving device can always operate within the constraints of its speed and memory availability. If sender and receiver both work at the same speed, then there will be no problem. But if at all the receiver is slower than the sender and the sender sends data at a faster rate, the receiver might lose some of the data frames because it is slow compared to the sender, and also it has low memory availability. Hence, flow control mechanism is used. The flow control mechanism provides a set of procedures which tell the sender how much data it can transmit before the data overwhelms the receiver. The receiving device here must be able to inform the sending device to stop the transmission temporarily before the limits are reached at the receiver or before the memory is completely filled. So, by default, any receiver should have a buffer or block of memory for storing information until they are processed. If it handles data on the go without any memory space, then the chances of losing data frames are high. Hence, the receiver will be equipped with a buffer or small block of memory. In order to provide a control on the flow of data or a control on the speed with which data flows between the sender and receiver, the data link layer provides two flow control protocols, stop and wait protocol and sliding window protocol. First, let us see the stop and wait method. In stop and wait method, the sender waits for an acknowledgement after every frame it sends. That is, a sender will send a frame and it will wait. The receiver, upon receiving the frame, will send back an acknowledgement saying that it has received the previous frame. Only when the acknowledgement is received, the sender will send the next frame. So the process of this alternate sending and waiting for a frame or waiting for acknowledgement continues till the end, till the sender transmits an end of transmission frame, or we call it as EOT frame. So till an EOT frame is sent by the sender, every time it sends a frame and waits for the acknowledgement. Only after the acknowledgement is received, it will send the next frame. So in this diagram, you can easily understand flow control. So the sender sends data. The receiver, after receiving, is sending back an acknowledgement to the sender. Only after the acknowledgement frame is received, the sender will transmit the next data. Again, receiver will give the next acknowledgement. Then sender will send the next data. So assume the receiver has a buffer capacity of storing 3 data frames at a time. So in that case, once its buffer is full, it will delay the acknowledgement frame. The receiver will send the acknowledgement frame after a delay. So this time delay will be helpful for flow control. So only after all these 3 data frames are consumed or processed by the receiver, only then the receiver will send back an acknowledgement to the sender, and sender will start sending the next frames. So this is how the stop and wait method is useful to accomplish flow control. The advantage of stop and wait method is a simple and easy to implement technique. The technique is quite simple. So the receiver, after checking in each frame, will send an acknowledgement to the sender. Only then the sender will send the next frame. But stop and wait also has a disadvantage. The disadvantage is the stop and wait technique is highly inefficient in bandwidth usage. So here you can observe that the transmission medium or the bandwidth or transmission capacity is made use of not only for the data frames but also for acknowledgement frames. For every data frame, an acknowledgement frame has to come back on the transmission media. This is a huge wastage of bandwidth of the network. And this is the major disadvantage of stop and wait protocol. So to overcome this disadvantage of stop and wait, another method called sliding window method was introduced for flow control in the data link layer. So in sliding window method, the acknowledgement frame is sent back by the receiver to the sender after several frames have been received. So the sliding window protocol has a capacity to maintain multiple frames in its buffer. So after sending multiple frames by the sender, it can expect an acknowledgement by the receiver. So, and also a single acknowledgement frame acknowledges multiple data frames in sliding window. So in sliding window protocol, the sender and receivers will maintain a sender window and receiver window respectively in order to keep track of the frames which have been transmitted and frames which have to be acknowledged. So in this figure, you can easily understand the concept of sliding window flow control method. So you can observe the sender has a sender window. This is a sender window. The receiver maintains a receiver window. And the frame numbers are 0, 1, 2, 3. These are the frame numbers. After frame 3, again the numbering starts from 0, 1, 2, so on. So the frame size, the window size here is 7. So it can maintain the detail of 7 frames. So the center window as well as receiver window size is 7 each. So you can observe here the sender window. Currently the window pointer is pointing. So the sender window can keep track of 2 frames at a time. Even receiver window keeps track of 2 frames at a time. So this box which is shown in dark color, this is going to move or slide over the window. So here you can observe how it slides. So first sender sends frame 0, next it sends frame 1. So after sending these 2 frames, upon receiving these 2 frames successfully, the receiver will send an acknowledgement frame. The acknowledgement frame will be numbered as 2. So this indicates, this number indicates that receiver is expecting frame 2. So when acknowledgement 2 is received by the sender, it understands that next it has to say, transmit frame 2. So as soon as the acknowledgement 2 frame is received, the sender window slides by 2 positions. So next 2 outstanding frames to be sent according to the sender is frames 2 and 3. And it sends frame 2. Say during transmission, frame 2 is lost due to some error. So whereas the next frame which is sent, frame 3 has received correctly. In this case, you can observe in the receiver window also has slided towards next 2 positions. It's pointing to frames 2 and 3. So upon receiving frame 3, the receiver observes that frame 2 was not received. Hence, it will send a negative acknowledgement NAC 2. So this indicates the sender that frame 2 is not yet received by the receiver. Hence, the sender understands that it has to send frame 2 now. So it sends frame 2. So you can observe the window, the center window has not yet slided to the next two positions because frame 2 is not yet successfully received. Okay, so this is how the sender and receiver operate using the acknowledgement frame. So they keep track of frames through the windows. So here, the window can hold the frames at either end, and it provides the upper limit on the number of frames that can be transmitted before the acknowledgement. So if you observe here, the window is pointing to only 2 frames. So this indicates the upper limit of how many frames can be transmitted before waiting for an acknowledgement. So here only 2 frames can be transmitted at a time, and to move to the next frame, an acknowledgement frame is desirable. That's the meaning of this particular point. So frames can be acknowledged even when the window is not completely filled. Okay, so there is no restriction that only after the windows are filled, the acknowledgement has to be sent. So even before the window is filled, the acknowledgement can be sent. And the size of the window is usually n minus 1, and the size of the window is n, and the numbers in the windows range from 0 to n minus 1. So if n is equal to 8, then the frames numbered are 0 to 7. Again, it starts from 0 to 7, again in cyclic order 0 to 7. So in the figure here, the size of the window is 4, and the numbers are 0, 1, 2, 3, 4. So after these 4 numbers, again the numbers repeat in cyclic order. If the size of the window is represented by n minus 1, then mathematically the maximum of n minus 1 frames can be sent before an acknowledgement. So when the receiver sends the acknowledgement, it includes the number of the next frame that it wants to receive, that we discussed in the figure. So if I take for an example, to acknowledge the string of frames ending the frame number 4, say 5 frames have been received, frame 0 to frame 4, the receiver will send an acknowledgement at 5, indicating that it's expecting to receive frame 5. Now coming to sender window. So at the beginning of the transmission, the sender window will contain n minus 1 frames. That is the size of the window. And when they are sent out, the left side boundary moves inwards and reduces the size of the window. Say if the size of the window is W and 3 frames are sent out, at this stage, the sender window size will be W minus 3. So once the acknowledgements have received, then the sender window expands, and expands by the number which will be equal to the number of frames which are acknowledged. So for example, if the size of the window is 7, and if frames 0 to 4 have been sent out and no acknowledgement has arrived, then now the sender window contains only 2 frames, 5 and 6. At this stage, if acknowledgement has arrived with number 4, which means that frames 0 to 3 have arrived undamaged, and the sender window will be expanded to include the next 4 frames. So this is what is shown in this particular figure. So the center window will contain, after the 4 frames, the center window will now contain the frames 5, 6, 7, 0, 1. So say here, frames 0 to 4, if they are acknowledged, now the center window will contain 5, 6, 7, 0, 1, 2. Now coming to the receiver window, at the beginning of transmission, the receiver window does not contain n frames, but it contains n minus 1 spaces in the frames. It will be completely empty. So when each new frame arrives, the size of the window shrinks. And for example, if the size of the window is W, if 3 frames are received, then the number of spaces will be that will be available in the receiver window will be W minus 3. Once the acknowledgement is sent, the receiver window expands by the number equal to the number of frames acknowledged. Say if 2 frames are acknowledged, the window will expand by 2. Suppose the size of the window is 7, the receiver contains 7 spaces for 7 frames. If 1 frame is received, then the receiver window will shrink, moving from 0 to 1. So now its capacity reduces to 6. So this is how the receiver window works. Say if frames 0 through 4 have been received, then the window will contain 2 spaces before an acknowledgement is sent. So after the acknowledgement is sent, it gets expanded by 4 frames. That's the meaning which is shown in this particular diagram of receiver window. So this is how the sliding window protocol works for flow control. So depending on how much is the speed of the receiver, it can delay sending the acknowledgement frame so that its buffers will not be overwhelmed. After it processes enough frames which were received, only then it may send its acknowledgement, thus avoiding the buffer overflow in the receiver. Thank you.